Let's talk a little bit about the concept of area. But before we do that, we'll review perimeter because perimeter is a related geometric idea and it's often confused with area. So the perimeter is the distance around the outside edge of a figure. So if you're given a figure, normally we tend to give figures that have straight sides just to make this kind of a little bit more straightforward, ha ha ha, math joke, but a little bit more easier to compute. We give a figure with straight sides and you can be given the distance of each side. So if I want to know what the distance around the outside edge of the figure is, we would just kind of go through the various outside edges, whatever those lengths are, and we would add them all up. Okay, so if you want, you can maybe think about this as the amount of fencing that would be needed to wrap around the outside edge of a figure. All right, so contrast that with an idea about area. So area is the amount of space inside of a two-dimensional or a flat figure. And we typically would measure area in square units, just because if you're given a flat figure, and I'll just kind of draw just a generic figure that has straight sides. If I want to figure out how much space is inside of here, I guess we could measure the space by seeing how many, I don't know, cotton balls would fill out the insides or how many macaroni noodles would fill out the inside or something like that. But one, those are not all the same size, right? Not in cotton balls maybe could be squished, or macaroni noodles are not all the same size exactly. But the other thing is we usually like to measure it with however the side lengths are being measured. So we want to make a connection. If my side lengths are being measured, for instance, in inches, then I want to be able to have an idea about how does that inches relate to what's happening on the inside of the figure. So then normally what we would do is we would measure the inside in square units, and the units match whatever the units are that we're measuring the sides. So if we're measuring the sides in inches, then I would make a square where each side of the square would be 1 inch. Okay, so I would make a 1 inch by 1 inch square, and I would take that square and lay it on the inside, and I would make a bunch of copies of that 1 inch by 1 inch square, and I would lay it on the inside. And then the idea is I would figure out then at the end how many of those squares filled up the entire figure, and whatever that answer is, we would report that number. You know, for instance, let's say on this picture I'm drawing right now, but just of a figure that with closed sides, and I'm putting a bunch of squares on the inside. I might say it's 20, and then 20, and then square inches. So we would then state what the unit is that I'm measuring it in. If I'm doing the fencing, and for instance my side length was, one of the side lengths was in 5 inches, then all of the other sides should also be measured in inches. So my final answer on a perimeter or fencing idea would be, for instance, I could say it would be 20 inches. Okay, so it would match whatever the units are that I'm measuring everything in. But if I'm doing area, since I'm measuring area in little squares, my final answer would be, for instance, 20, and I could say square inches. But the shorthand for, instead of writing out the words square inches, if we could say IN is my abbreviation for inches, and we will put a little 2 on there. That kind of looks like an exponent, but it's really not. You can't obviously apply a mathematical operation to a word, but this is telling me that it's a kind of a shorthand for saying the word square. So if I'm connecting this back to this, maybe it's an outdoor example of perimeter being the fencing, then maybe I could think about area as being the amount of grass that I would need to kind of fill in my yard, so to speak. All right, so that's the difference between the two ideas. I can obviously talk about the same figure, but looking at two different types of ways to measure it. Just to contrast the ideas between perimeter and area again, let's take a look at a couple different figures, and for each figure we will find its perimeter and we will find its area to kind of explore how these ideas are related, but they're also exploring something very different about what's happening on the figure. All right, so I have 3 figures down here. just made of a series of various squares or boxes. And they're kind of all arranged differently. So on the first figure, I've got 2 rows with each row having 4 boxes stacked one on top of each other. So it just kind of looks like a rectangle broken up into 8 boxes. The area of this figure is how many squares it took for me to make this figure. So it took for me 1, 2, 3, 4, 5, 6, 7, 8 squares to make this. Now I don't know actually how long these are. We weren't told that this was measured in inches or meters or anything like that. So we're just going to talk about everything in terms of just generic units. So this area of this figure would be 8, and we would say 8 square units. Okay, so 8 units were each, or 8 squares, and each square is 1 unit by 1 unit big. Now, if you look over here actually at the second figure, just to kind of maybe look at this idea about area, the second figure, 1, 2, 3, 4, 5, 6, 7, 8. So this also took 8 square units to make it. But this one obviously is set up a little bit differently, right? I've got 2 rows of 3 boxes here, and then this one square off on the upper left, and then this other square off in the middle of that second row. But it still took me 8 squares to make it. For this last figure over here on the right, 1, 2, 3, 4, 5, 6, 7, 8. So this also is 8 square units. But this one again looks a little bit different. This kind of maybe looks like a Y with 2 boxes going up, 3 boxes coming down for the stem of the Y, and then this 1 box that's coming off the stem of the Y at the very bottom to the left. All right, so all 3 of these figures have the same area. It took me the same number of squares to make it. We're going to find that their perimeters, though, are very different. Coming back up to this first figure, how many units does it take for me to walk around the outside edge of the figure? All right, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it takes me 12 units to walk around the outside edge. For the second figure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one takes me 14 units to walk around the outside edge of the figure. And then finally for this last one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this one took me 18 units to walk around the outside edge of the figure. So as I got to other figures, there was kind of more edges of the boxes exposed, so that made the perimeter a little bit longer. Now, while you might normally be asked to find the perimeter in an area of more typical shapes like rectangles or triangles or trapezoids or something like that, I think these examples just kind of highlight the difference between what you're finding when you find perimeter versus when you find area.